All right, we've got an American Beauty resistance soldering test and evaluation project to do here. We're going to make a little video. Hopefully that will help the end user to determine the best way to do this project in-house. They've supplied us with some of these ferrules that they want soldered together. So what we're going to do is, with the materials they've supplied, we've got a 32nd inch diameter solder wire. And what we do is we take this wire and we wind it around a piece of the ferrule that we're doing. And we wind several coils of this around here. And what we do is make it like a spring. Now once we've done this and made several turns on it, we slide it off and we cut these apart to have these little preformed rings that we're going to use for soldering. Okay? Now the flux I'm going to use on this is a fairly aggressive flux. This looks kind of like stainless steel, but it's not. It's a nickel copper zinc alloy, and it's going to take a little bit of a more aggressive or acidic flux to do this than you would use for something like a copper or silver finish. So we'll just put a little bit of that on there, and I'm going to go ahead and insert this just to kind of spread that flux a little bit. Then what I'm going to do is I'm going to take these little preforms, and because I've already done this a couple times, I figure it takes like 2 of these worth of solder to get a good saturation down into the joint. So I'll put 2 of these rings on here. Of course, make sure after you do this type of work that you wash your hands really good, because you don't want any of this stuff in the way when you're eating or whatever after the fact. Okay, so I've got the preforms on here. Now I want to show you real quick, I modified these electrodes slightly for this application. And what I did, if you can see this, I started with a jeweler's file, kind of like a rat tail, and I put that between the electrodes so that I could mark this so that both of the channels on the electrodes would be in alignment with each other. Then I went back in with another file, and this one's got about the same radius as the ferrule I'm going to be working with. So I used that, and then I filed out these channels larger so that I could get a nice fit on these on the ferrule that I'm going to be heating. Okay?
What does the nice fit do?
Well, what that does is it's going to allow the thermal energy to spread just a little bit better into the alloy when I'm heating it, so I don't have such an extreme hot spot at the point of contact. If I was going a radius to a flat, then I have a more narrow point of contact. So this gives a little wider point of contact. Now I don't want full contact around it, because then I start to lose some of the resistivity, okay, and I lose a little bit of the thermal energy. It's not drastic, it's one of those trial and error things that you learn as you go, but you do get a little better ability to hold the part if you channel it, and you do spread the heat just a little bit better for thermal saturation. And you're going to see now I'm using the 10507 system, okay, and that involves or includes an 1100 watt power unit, and then this is a 105-258 hand piece with the carbon electrode blocks. All right, I've got a run light here so that you can actually see the dwell time when I heat this up. I'm on the A and C hookup on this, and I'm about 2/3 of the way up the dial as far as my voltage output goes. Let me turn the fume extractor on. Okay, and just watch down here where the preform is at, and you'll actually see the solder wetting and see about how long it takes to do this. Okay, there's one, and I'm going to go ahead and do another one.
Now if we turn up the heat on that, on the power, can we, or do we want to turn up the power on that?
This is again one of those, with the test and evaluation that we're doing, everything's trial and error, but it's the same thing with an end user, trial and error. And so what they can do is they by all means can adjust the heat up, which will speed up the process or lower the dwell time. Now, the problem with that in some cases, okay, is if you actually do it too hot, then you can end up with a score mark, a burn mark, or what have you at the point of contact. You can have thermal discoloration of the materials you're working with. Now, again, sometimes that makes a difference and sometimes it doesn't. If you can go back in and clean that after the fact, you can see here how quickly that cools off. I can actually grab this in my hand and hold it now. You can kind of see the solder joint, nice little fillet there. Okay. Again, you can adjust the thermal energy to affect the dwell time. You do that in accordance with what you're trying to achieve. I'm going to push down on this one a little bit just to make sure that I'm getting this to fit down in while it's heated. Okay. And I'll go ahead and do the second one just to give you another bird's eye of how this is working for us. And you saw that drop slightly into the channel, so we know that that's fully seated. And that concludes our test and evaluation for this project.
And have a nice day.